Okay, so in this video we're going to talk about the gradient of velocity time graphs. Okay, so we're going to look at section A of this graph to begin with. If you remember, in a previous video we said that the gradient of a velocity time graph is equal to acceleration. Okay, so the gradient is equal to the acceleration of the object in this graph. Now the gradient is equal to change in the y value divided by the change in the value on the x-axis. So if we do the gradient for section A here, okay, we're going to just draw a little triangle. Hopefully you can see that on the video. Now if you look at this, is the change in the y value. Okay, it's the change in y is this difference from here to here on the y-axis. Okay, and that happens to be, if you look at it to start off with, you're at 0 meters per second on the y-axis, and by the end of this section you're at 10 meters per second. So the change in y here, okay, the change in y is equal to 10 take away 0. Now the change in x, if you look at the start you're at 0 and at the end you're at 20. So the change in x is equal to 20 minus 0. So when we work out the gradient, the change in y is 10 minus 0. The change in x is 20 minus 0. So that gives us 10 over 20, which is 0.5 meters per second squared. Okay? And that's your gradient of section A. That is the acceleration of the object during section A. Now, if you think about it, the change in y, the y value, is the velocity, and the change in the x value is the time. So when we work out the gradient, we're doing the velocity, or actually we're doing the change in the velocity, and we're dividing that by the time. Now change in velocity over time is equal to acceleration. That's the equation for acceleration. So this is the same as what we're doing with the gradient calculation. So that's why the gradient of a velocity time graph represents the acceleration. So if you want, you can use this equation, and another way of writing this is acceleration is change in velocity divided by time. You can either use that equation or you can use the gradient method. It doesn't matter, it's the same thing. Now let's look at section B. Section B here, we're going to work out the acceleration over this here. Now the first thing we should say is this: it's steeper than section A. So if it's steeper, if the gradient is steeper there, that would tell us that the acceleration should be bigger than in section A. So we'd expect an answer bigger than 0.5. So let's do that. Section B here, okay? So the gradient, let's do the gradient method, is equal to change in y over change in x. Now, if you look at the start here on B, when you start B here, this is your change in y. Your change in your y value is equal to, well, when you start section B, you're already moving at 10 meters per second. At the end of section B, you're at 25 meters per second. So the difference is this here. So it's 25 take away 10, which is equal to 15 meters per second. Your velocity has increased by 15 meters per second in section B. Now the change in x is this bit here, okay? So that change in x, you're starting at 20 seconds and you're ending section B at 40 seconds. So your change in x, and I'll put it up here, okay? The change in x here is equal to 40, because that's the end of section B, minus 20. Okay, because that's the start of section B, and that's 20 seconds. So you can now put these values into here. So our gradient for section B is equal to the change in y, which is 15, divided by the change in x, which is 20. So 15 divided by 20 is going to give you 0.75 meters per second squared. Okay, because it is 1.5 divided by 2. So That makes sense because that gradient is greater than this one, that acceleration is greater than this one, which is what you'd expect because the gradient is steeper. Now let's just have a final look at section C. So section C here, so the gradient again is equal to change in y divided by change in x. Okay, now for section C here, you start off at 25 meters per second and you end at 25 meters per second. So your change in y here is equal to 25 take away 25. The change in something is always the final value take away the initial value. So for section A, the final value of the velocity was 10 and the initial was 0, so it was 10 minus 0. Here, the final value of velocity is 25 and the initial value is 25. So 25 take away 25 is going to give you 0. And that makes sense because your velocity has not changed during section C. Now your change in x, you start off at 40 seconds and you go up to 60 seconds. So the change in x is your final time, take away your initial time, 60 take away 40, which is 20. So you're going to get 0 over 20, which gives you 0 meters per second squared. And that makes sense because there's no gradient here. The graph is horizontal, no gradient, no acceleration. You're moving at a constant velocity. Okay? Now finally, let's have a look at section F. Now the only issue here is Okay, so we're going to talk now about the gradient of section F. Okay, now if you look at section F, this is section F here, from here to here. Okay, now your change in y here, you're starting off at 50 meters per second on your y-axis, and you're going down to 0 meters per second. So your change in the y value is equal to the final value on the y-axis, which is 0, take away the initial value, which is 50. That's your final y value. Your initial y value is 50. So it's 0 take away 50, which is going to give you minus 50, which makes sense because in this section here, your velocity is decreasing. So you're decelerating. Remember we talked about that earlier. Now your change in x is equal to the final value on the x-axis minus the initial value on the x-axis. So the final value is 120, the initial value is 100. Right, so that's 20 seconds, and this was meters per second. So the gradient here is equal to minus 50, that's your change in y. Remember the gradient equals change in y over change in x. Whoops. Okay, so it's minus 50 divided by 20, which is going to give you minus 2.5 meters per second squared. Okay, so that is the gradient of part F. It's a minus value. Now, why is it a minus value? The minus value just represents that you're decelerating, or it's a negative acceleration. You're slowing down. Your velocity is decreasing. Okay, now just quickly, let's look at another way of doing this same problem. Part F here, okay. Whoops, part F here. Remember that acceleration equals change in velocity divided by time. Okay, so the acceleration here could also be calculated using that equation. So your acceleration, the change in velocity, well, you're going from 50 down to 0. So it's going to be your final velocity take away your initial velocity, so 0 take away 50, divided by the time that takes place over, which is 20 seconds. So that will be minus 50 over 20, which gives you minus 5 over 2, which equals minus 2.5 meters per second squared. So either way you do it, either using that equation or the gradient method, it gives you the same answer. Okay, so that's gradients on velocity time graphs.